Okay, Assalamualaikum and good day everyone. Alright, so right now I am going to show you how to answer the questions in tutorial 5. Okay, so we have here two questions. Okay, the first question here is related to short run production. Okay, why? Because we have here the first input, which is capital. Okay, so capital in this case is considered as fixed input. Okay, because the number remains the same regardless of the production here. Okay, so you have different production, but the number of capital is the same. So capital is a fixed input. And then you have labor, which is the variable input. Okay, because the number keeps changing when the number of production is changing. Okay, so you have two different types of input here, fixed and variable input. Okay, now what you need to do here is you have to find or you have to calculate the average product and the marginal product. So you are given different number of labors here, and you are given the production for each number of labor, meaning when you increase labor from 1 to 2, 2 to 3, 3 to 4 and so on, the production will change. Okay, so you can see here in the beginning the production will increase until it reach maximum level and the production starts to decrease. Okay, so now you have to calculate the average product and the marginal product. That is for question A here. Okay, so to calculate average product, if you look at the slide, okay, the formula to calculate average product is the total product, okay, you divide with the number of variable input, which is labor in this case. So what you need to do is you have to calculate for each number of labor. Okay, you have to calculate the average product for each number of labor. So for example, the first one here, 1000, you have to divide with 1. So the average production when Mila here hire one labor is, this labor can produce 1000 unit of products, okay, on average. When Mila hires 2 labors, the total production would be 2200. So the average production would be 2200. You divide with 2. So what you will get is 1100. And then 3600, you divide with 3, you will get 1200. And then you do the same calculation for the rest of the empty table here. Okay, so you have here 1000, and then 8040, 700, 500, 200. So you have your average product for each unit of labor in the production. Okay, so now what you need to do next is you calculate the marginal product. So marginal product is actually the additional product that the extra labor can produce. Okay, if you add another labor in the production, what is the additional production that you can get? Or in this case, Mila can get lah. Okay, so for example, when the number of labor is 1, okay, before this 0 labor, okay, when Mila add 1 unit of labor, the total product is 1000. So to calculate the marginal product is the change in the total production must be divided with the change in the number of labor hired in the production. So in this case, the previous production would be 0 lah, because the number of labor is 0. No labor, no production. So you consider here as 1000 minus 0, that is the change in total product, and 1 minus 0 for the change in labor. So what you will get is also 1000 for the first marginal product here. Okay, next is 2000. Okay, the change in total product is 2200. You minus with 1000, that is the change in total product, and then you divide with change in labor, which is 2 minus 1. Okay, so what you will get is 1200. So what does it mean here is when Mila hire another labor from one labor now she hires 2 labours, the additional labour can produce additional 1,200 products. Okay, that is the marginal product in this case. Okay, alright, so now let's calculate for the rest of the figures here. 1,400 here, and then 400, 200, 0, and then it will become negative 700 and negative 1,900. So you get negative because your total product has decreased. So there will be no additional production in this case. Okay, and you get 0 here because the total product is not changing from 5 labour to 6 labour. So there is no additional production here. So the marginal product will be 0. Okay. Alright, so you have completed the table here for question A. So now what you need to do is you have to graph or plot the total product, the average product, as well as the marginal product on a graph paper. So meaning you will have 3 curves, okay, for total product, average product and marginal product on one graph. Okay, so in that one graph you have 3 curves. So what you will get in your graph is basically this one, which I have constructed using Excel here. Okay, so I have ignored the stages first. Okay, now we are focusing on how to plot the total product, average product and marginal product in this one graph. Okay, so what you will have here is the labour on the x-axis. Okay, so you have labour here, x-axis, which is labelled here, this one. Okay, and then you have total product, marginal product and average product on the y-axis. So let me put the axis so you can see clearly. Okay, so you have plotted, okay, let's say you have plotted the total product, marginal product and average product in this one graph. So the red one here, okay, the red curve here is the total product, okay, which is labelled here. And then the purple one here is the average product. And the orange one here is the marginal product. Okay, so this is what you get after you have plotted the data from your table. Okay, you can do the scaling for total product, marginal product and average product because the numbers is in thousand, mostly is in thousand. So you can do a 1,000 scale. Okay, 1,000, 1,000. You can do 500, but your graph will be a bit bigger lah. Okay. Alright, so it is nice if you can do 1,000. Okay, so this is what you will get. Right, so I hope you will have no problem in plotting the graph using, especially when you use graph paper. Okay, next, let's look at question C here. Okay, so question C is asking at what number of labour do the stage 1 and stage 2 end. So in my video for topic 5, I have explained that a short run production will have 3 stages. Okay, so how do you determine whether the production is in stage 1, stage 2 or stage 3? Alright, so how do you divide the 3 stages? Okay, the first stage, okay, for you to know the first stage, okay, stage 1. Okay, so the condition for stage 1 is it will end when average product reaches maximum. Okay, that is the first condition. And the second condition is when average product equals to marginal product. So if you look at this graph here, okay, you have the average product. Okay, the average product is the purple curve here. Okay, and average product is at maximum, okay, at this point. Okay, and average product and marginal product intersects at this point. So this is the point where average product is at maximum and marginal product equals to average product. So it fulfills the two conditions. So this is basically where stage 2 will end. Okay, so if you look at this table here, okay, average product is at maximum at this point. Okay, alright. So when you want to show the differences between the stages, or you want to divide the graph into 3 different stages, you have to do a line. Okay, so let me put this one here. Okay, so you draw a line at that intersection between MP and AP, and you label the first stage as stage 1. Okay, so that is your stage 1, when from 0 until 3 number of label. Okay, so basically what you can say here is stage 1 will end when the number of label is 3. So if you use graph paper, you can get the number of label here is 3.4. The line is at 3.4, but you have to round off because you are talking about label, human, so you cannot have it in decimal point. So you round off to the nearest figure, which is 3. Okay, so stage 1 ends when the number of label is 3. Stage 1, 3 labels. It ends at 3 labels. Now, the condition for stage 2 is the marginal product equals to 0. That is where the stage 2 ends, or when total product is at maximum. Okay, so the condition where marginal product equals to 0 and total product is at maximum is here. This is where marginal product equals to 0, and this is where your total product is at maximum. So that is where your stage 2 ends and stage 3 begins. So you put a line there to divide between stage 2 and stage 3. So stage 2 is here and stage 3 is here. So you have to label lah. Okay, label stage 1, stage 2 and stage 3. Alright, so stage 2, you can answer here, stage 2 ends when the number of label is 6. Okay, which is here. Alright, from the graph. Okay, so that is for question C. Okay, so based on the diagram, which is the graph, okay, that you have done in question B here, this is the diagram. Okay, explain the relationship between average product and marginal product. So your explanation must refer to your graph here. So let me clear this one first. Okay, so what you need to do is you explain what happens between AP and average product and marginal product curves. So you can see here, when marginal product, the orange curve here, is above the average product, which is the purple curve here, the average product is increasing. Okay, when marginal product, the orange one, is below average product, the purple one, okay, average product will start to decrease. So you can see, you notice here, average product increase here and average product decrease here. Average product increase at stage 1, average product decrease at stage 2. Okay, and when at this point, okay, when marginal product equals to average product, okay, means marginal product intersects with average product, the total product is at maximum. So you can see the purple curve here is at maximum at this point. Okay, so your explanation, you can say, you can actually get this explanation from the slide. Okay, so when MP, marginal product, is above AP, AP is increasing. When MP is below AP, AP is decreasing. And when MP is equal to AP, AP is at maximum. You put it in full sentence, okay? I put it in short form. Alright, so that is the relationship between average product and marginal product that you can observe from the graph. Okay, based on the diagram, question E. Based on the diagram, explain the relationship between total product and marginal product. So now you have to look at the total product curve and marginal product curve. Okay. So the red curve, you compare it with the orange curve. Okay, so what you can see here is when total product, so at stage 1, you notice that the total product curve is increasing rapidly, meaning the curve is quite steep. Okay, dia macam curam sikit lah dia punya curve. So what happens at marginal product is marginal product akan jadi positif. Marginal product will increase. So the orange curve will increase the marginal product. Okay, that is what happens at stage 1. And when your total product starts to increase at a decreasing rate, meaning your total product increase but it no longer increases steeply. Okay, the curve is no longer steep. It becomes flatter. Okay, dia lepeh sikit dekat stage 2 ni. Okay, so at stage 2, TP is a bit flatter. So what happens at marginal product is marginal product decrease. Okay, meaning it shows that the additional production is declining. Okay, in this production. And when total product is at maximum, you notice here total product is at maximum. Okay, your marginal product equals to 0. Okay, so that is the third relationship. Now, at stage 3, when total product starts to decrease, okay, the marginal product will be negative, showing that the additional production is decreasing. Okay, so marginal product will be negative. So those are 4 relationships that you can explain here. Okay, so the first one is when total product increase at increasing rate, marginal product will increase. Okay, when total product increase, this is at stage 2, increase at decreasing rate, marginal product will decrease. When total product reaches maximum, your marginal product will be 0. And then at stage 3, when total product decrease, your marginal product will be negative. Okay, so those are the 4 relationships between total production and marginal production that you can observe from the graph. Okay, last question. Does the firm operate in the short run or in the long run? And explain your answer. So, in the beginning of the topic, I have explained about the differences between short run and long run production, in which short run production, it involves 2 inputs, which are fixed input and variable input, meaning the producer doesn't have much time to increase their capital. But in the long run, okay, we assume that all inputs are variable inputs, meaning you can increase or you can change the number of labor, the number of capital in your production. So all inputs are variable. So in this case, if you look at the table, it says that your capital is fixed. It remains the same. So you have fixed input in this production. Therefore, this production is in the short run. So you can put the reason because there is fixed input in the production. Okay, fixed input and variable input. or you can just say because there is fixed input. That is also enough. Okay, if you answer that way. Alright. Okay. So question 2 here is regarding the long run production. Okay, in which in the long run, okay, we understand that all the inputs in a long run production are variable inputs. So in this case, you can see from this table that we have two inputs, which are capital and labor, and the number of capital we have 1, 2, 3, 4 and 5, meaning it can change, as well as labor we have 1, 2, 3, 4 and 5. Okay, so we can see here that the number of capital and labor is changing at different level of production. Okay, based on the above table for question A, what are the combinations of labor and capital to produce 600 pieces of bricks? So these figures, okay, on the table here are the productions of bricks. Okay, so we have here in this question, it is asking for you to find the number of labor and capital that can be used, okay, in this production to produce 600 pieces of bricks. So what you need to do is you find 600 production of bricks in this table. Okay, so we have here 1, okay, 2, 3 and 4. So we have different combination of capital and labor to produce the same amount of product, okay, which is 600. So what you need to do is you just list down the combination of capital and labor. Okay, so for the first one, you have 1 labor, 5 capital. 1 capital, 5 labor. Okay, so 1 capital, sorry. This is capital, this is labor. So 1 labor, 5 capital. Okay, and then here you have 2 labor, 3 capital. And then here you have 3 labor and 2 capital. And then here you have 5 labor and 1 capital. Okay, so you have 1, 2, 3, 4 different combinations of labor and capital that the producer can use to produce 600 pieces of bread. Okay. Next is on the graph paper, plot an isoquant curve to show the combination of labor and capital to produce 600 bread. So I do it in Excel. Okay, so you have here on the y-axis is capital, x-axis is labor. You can also put labor on the y-axis and capital on the x-axis. It doesn't matter. Okay, so you boleh terbalikkan pun tak ada masalah. You will get the same curve. Okay, so this is what you get after you have plotted the combination here. Okay, so the first one is 1 labor, 5 capital. 1 labor, 5 capital. So it should be here. And then 2 labor, 3 capital. 3 labor, 2 capital, and 5 labor, 1 capital. So this is your isoquant curve. Okay, as you connect the combinations. Okay, alright. Next, give 3 characteristics of an isoquant curve. Okay, so the characteristics of isoquant curve is actually the same as the characteristics of indifference curve. Okay, you have the same shape, the same concept. Okay, but this one is in terms of production. Indifference curve is in terms of satisfaction. Okay, so the first characteristic is indifference curve slopes downward from left to right. So it slopes downward from here to, from this point to this point, it is sloping downward. That is the first characteristics. It is convex to the origin. Convex meaning it bows downward towards the origin. This is origin. Okay, the further the isoquant curve from the origin, the larger the output. If you have different number of isoquant curve, which is what we call as isocom map. So you have here IC0, IC1, IC2. So the higher the number of isoconcurve, meaning the higher the number of production. For example, let's say this is 800, this is 900, this is 1500, for example. Okay, isoconcurve never intersect with each other. That is the same concept as what you can find in indifference curve. Okay, because the same number of different number of capital and labor, the same number of capital and labor cannot generate different number of product. Okay, meaning if you hire 5 labor and 1 capital, you cannot get 800 products and 1500 products at the same time. Okay, meaning if you hire 5 labor 1 capital, you will only have a certain level of production at that particular time. So isoconcurve 0 and isoconcurve 1, for example, they will never intersect with each other. Okay, alright. And then question D, differentiate between increasing return to scale and decreasing return to scale. So what do we mean by return to scale? It is talking about how much output that we can get, or how much is the increase in input when you increase how much is the increase in output when you increase the number of input in your production. So it is talking about the relationship between input and output. Okay, so for increasing return to scale, okay, how do you define increasing return to scale? Is an increase in the number of input, increase in the number of input will cause a higher increase in the number of output. Okay, for example, if input increase by 50%, okay, output will increase even bigger, let's say 100%. Okay, that is increasing return to scale. Alright, meanwhile, decreasing return to scale, okay, decreasing return to scale is when an increase in the number of input will cause a smaller increase in the number of output. For example, if input increase by 50%, output will only increase by 40%, for example, which is smaller than 50%. That is what we mean by decreasing return to scale.